Question 1. In Azure Machine Learning, what is the top-level resource that acts as a centralized place to manage compute targets, data stores, experiments, models, and endpoints? Option A, Azure Kubernetes Service, AKS. Option B, Azure ML Compute Instance. Option C, Azure Machine Learning Workspace. Option D, Azure Databricks. The correct answer is Azure Machine Learning Workspace. Here's the explanation. The Azure Machine Learning Workspace is the foundational resource that serves as the central hub for all Azure ML activities and asset management, providing a unified environment for the entire machine learning lifecycle. Question 2. A data scientist needs to perform distributed training of a deep learning model that requires significant computational power and needs to scale out dynamically. Which Azure ML compute target is most appropriate for this scenario? Option A, Azure ML Compute Instance. Option B, Azure Kubernetes Service, AKS, attached as a compute target. Option C, Azure ML Compute Cluster. Option D, Azure Databricks for Spark-based ML. The correct answer is Azure ML Compute Cluster. Here's the explanation. Azure ML Compute Clusters are scalable, multi-node compute resources specifically designed for distributed training and hyperparameter tuning, capable of dynamically provisioning and scaling VMs as needed. Compute instances are more for single-node development, and while AKS can be used, compute clusters are the direct, managed Azure ML offering for scalable training. Question 3. Which Azure machine learning feature automates the iterative tasks of model development, including feature engineering, algorithm selection, and hyperparameter tuning, to identify the best performing model for a given dataset? Option A, ML pipelines. Option B, model registry. Option C, hyperparameter tuning. Option D, automated machine learning, AutoML. The correct answer is automated machine learning, AutoML. Here's the explanation. Automated machine learning, AutoML, is the feature that automates the entire process of finding the best model by iteratively trying various algorithms, featurization techniques, and hyperparameter combinations, significantly accelerating the experimentation phase. Hyperparameter tuning is a specific component that AutoML leverages. Question 4. What is the primary goal of automated machine learning, AutoML? Option A, to replace data scientists entirely with AI. Option B, to automate the end-to-end process of applying machine learning, making it more accessible. Option C, to manually fine-tune model hyperparameters for optimal performance. Option D, to develop custom machine learning algorithms from scratch. The correct answer is, quote, to automate the end-to-end process of applying machine learning, making it more accessible. Here's the explanation. The primary goal of AutoML is to democratize machine learning by automating the end-to-end pipeline, reducing manual effort, time, and specialized knowledge required for model development. Question 5. Which of the following tasks is *not times typically automated by an AutoML solution? Option A, data preprocessing and feature engineering. Option B, algorithm selection and hyperparameter tuning. Option C, defining the business problem and collecting raw data. Option D, model evaluation and validation. The correct answer is, quote, defining the business problem and collecting raw data. Here's the explanation. AutoML focuses on automating the technical aspects of model development: preprocessing, feature engineering, algorithm selection, hyperparameter tuning, evaluation. Defining the business problem and initial data collection are human-driven steps that precede AutoML. Question 6. A startup with limited data science resources needs to quickly develop and deploy a predictive model for customer churn. They are considering using an AutoML platform. What is a key benefit AutoML offers in this scenario compared to traditional manual ML development? Option A, It provides complete granular control over every line of model code. Option B. It eliminates the need for any human oversight in model deployment. Option C. It significantly reduces the time and specialized expertise required to build a competitive model. Option D. It guarantees 100% accuracy for all predictive tasks. The correct answer is, it significantly reduces the time and specialized expertise required to build a competitive model. Here's the explanation. AutoML's core benefits include accelerating the ML development lifecycle, reducing the need for deep ML expertise, and enabling faster experimentation, which is ideal for organizations with limited resources. Question 7. What is the primary characteristic of Azure ML Designer that makes it accessible to a broader audience? Option A. It requires deep Python programming expertise for all tasks. Option B. It offers a visual, drag-and-drop, no-code/low-code interface. Option C. It is exclusively for deploying pre-trained models. Option D. It only supports advanced neural network architectures. The correct answer is, quote, it offers a visual, drag-and-drop, no-code/low-code interface. Here's the explanation. Azure ML Designer is described as a user-friendly, visual, drag-and-drop interface that enables users to build, train, and deploy ML models without writing extensive code, making it accessible to a broader audience. Question 8. After successfully training and evaluating a machine learning model using Azure ML Designer, what is the crucial next step before the model can be deployed as a web service? Option A. Exporting the model to a local file system. Option B. Registering the model in the Azure ML Model Registry. Option C. Rewriting the entire pipeline using the Azure ML SDK. Option D. Manually tuning hyperparameters via a command line interface. The correct answer is registering the model in the Azure ML Model Registry. Here's the explanation. The how it works and exam tips sections emphasize that upon successful training and evaluation, the trained model must be registered in the Azure ML Model Registry before it can be deployed. Question 9. Which type of Azure ML compute target is typically used for scalable training of machine learning models within Azure ML Designer pipelines? Option A. Azure Virtual Machines, VMs. Option B. Azure Machine Learning Compute Instances. Option C. Azure Machine Learning Compute Clusters. Option D. Azure Functions. The correct answer is Azure Machine Learning Compute Clusters. Here's the explanation. The key features/components and exam tips sections specify that Azure Machine Learning Compute Clusters are used for scalable training and batch inference, distinguishing them from compute instances, which are for development/testing. Thanks for watching. Please subscribe to my channel